Top, quadrilateral. All right, any four-sided figure can be considered a quadrilateral. Now, there's different types of a quadrilateral, though. Different types. Now, you see how they're broken up into three families. And there's a reason why they're broken up into three families, which I'll go over after I introduce the first family. The first family here is the parallelogram family. We're actually going to spend the next 3 days covering the parallelogram. There's a lot to talk about. Who is part of the parallelogram family? Who is part of the parallelogram family? Let me introduce you first here to Randy, the rectangle. The rectangle is part of the parallelogram family, along with Rosie, the rhombus. The rhombus, part of the parallelogram family. And then you'll see the one right at the bottom, sometimes referred to as the golden child. All right, maybe some of you guys can relate. I certainly can. All right, my poor sister. This is Susie, the square. All right, Susie, the square. We will spend a day talking about the square and why it is so special. Now, why are all these grouped together? Why isn't one over here or one of these over there? Why are all these grouped together? Because they all share something in common. Both pairs of opposite sides are parallel. So everyone remember the arrows for parallel? Both pair of opposite sides are parallel. And that is the same through all of these figures, but not the rest of the families. All right, so that is why all the parallelograms are grouped together. The opposite sides are parallel. Let me introduce you to the second family. This is the trapezoid family. The trapezoid family, starting off with Tony, the trapezoid. Okay, Tony, the trapezoid, and then we got the souped up version, the upgraded version right underneath, and that is Isaac, the isosceles trapezoid. So why are these grouped together and not in the parallelograms? They only have one pair of opposite sides parallel. That's it. They only have one pair of opposite sides. So that's why they're grouped together. And then you see the last one, all by itself. The black sheep, the outcast. Maybe now some of you can relate. And this is Kyle, the kite. Not the diamond, the kite. Why is it all by itself? No pairs of parallel sides. Has nothing parallel. Okay? So eventually, because you guys know this unit goes to after break, we're going to talk about all these figures. But for the next 3 days leading up to next week's quiz, it's all going to be about the parallelogram. All right? All about the parallelogram. All right? So let's start talking about it. Now that you know the family, let's start talking about one of the members, which is the parallelogram. Couple things I want to show you. First is I am never going to write the word parallelogram again. That's too much work. I'm not going to write it again. Do you remember the symbol for parallel? What was the symbol for parallel? I'm not talking about the arrows on the diagram. I'm talking about the actual symbol here. What's up, Simon? Need a little more than that, right? All lines are straight. They are vertical, correct. They are vertical. So from here going forward, here's how I'm going to write the word parallelogram. The parallel symbol dash ogram. All right, that's how I'm going to, you can use it. Feel free to use it. Please just don't say 11ogram. Okay, it's parallelogram, everybody. Next thing I need to show you, and this goes for any quadrilateral. When we did triangles the last 2 units and I said, hey, that's triangle ABC, did it really matter where A, B, and C went? Never mattered. Now it matters. Okay, when we label any quadrilateral, the order matters. So let's call this parallelogram ABCD. The order matters now. You cannot just plop ABCD anywhere you want. Okay, you can plop A anywhere you want. You got to start at some vertices. So put A anywhere you want, at any of the vertices. Now, when you label it going forward, it has to be in a clockwise or counterclockwise direction. We cannot not jump diagonally. We can't go A, B. All right, that's going to throw off all the angle names. We have to go clockwise or counterclockwise when you label a quadrilateral. So please never jump diagonally. All right, so we're good on some of the basics. Now let's hop right into it. In a parallelogram, there are 5 properties I need you to be aware of. I do not expect you to know them by the time you leave. Let's put a deadline at Tuesday. All right, Tuesday by the time you leave, I need you to know these 5 down pat. And I think you will anyway because you'll use them so much. We already know one of the properties. That's why they're all grouped together. What did we say? Why are they all grouped together? Because they have opposite sides are. Why were they all grouped together? Opposite sides are parallel. So let's mark that on your diagram up above, your parallelogram above. Let's put those arrows on. All right, next up. I'll leave this up to you guys. What do you think? Take a guess. I just throwing the challenge out there. Last period, got at least 2 more. And there's significantly more of you in here. What do you think about a parallelogram just by guessing or looking at the diagram? Taking a chance. Go ahead, Cork.
Opposite angles.
All right, there we go. Opposite angles congruent. That is another property. How do I mark that again? How do you mark angles congruent? Arc marks, right? So A is congruent to C, and then separately D is congruent to B. Good? You want to guess another one here to match them, or maybe it doesn't matter. What do you think? Go ahead, Simon.
Opposite sides are congruent.
Got it. There we go. Opposite sides congruent. Good work. Yep, opposite sides are congruent. All right, you ready for the last 2, which I don't think you'll get here. Don't write this down, but I want you to help me get property number 4, though. Don't write it down, but you're going to help me get property number 4. Let's say angle A is 100, which means angle C has to be 100. Opposite angles congruent. Yesterday, you learned how many degrees in every quadrilateral? 360, right? So 360, I'm down 200 degrees. Now I have 160 degrees left for these 2 congruent angles. What are B and D going to measure then if I have 160 left? 80, 80. Everyone's in agreement with that. Good. Now, can you tell me a property? The 4th property. 180, 180. Dylan, what's up?
Same side angles are supplementary.
Yeah, I'm going to use a different term than same side, but yes, you're absolutely correct. I'm going to use the word consecutive. Consecutive, because consecutive means to you 2 in a row, right? Consecutive angles are supplementary. All right, consecutive angles supplementary. So 2 in a row add up to 180. And the last one, I don't think anybody's going to get because I don't even have them drawn on the diagram. I'm just going to get rid of all this on my diagram so you can clearly see it. All right, from yesterday's class, I need somebody. What am I drawing in right now that connects A to C? What's that line segment called again? That's A, Bailey? Diagonal, yep. And I can draw in one more, can I? From B to D, yep. All right, here's what I'm going to mark on it, and you tell me the 5th property. What do the diagonals do? Bisect each other, right? Because they're cutting each other into 2 congruent parts. So your 5th and final property, the diagonals, when they are drawn in, the diagonals bisect each other. But you have to have diagonals for this to happen. And I have a little challenge question for this above average math class. Let me go back to those diagonals. Can somebody give me a vocabulary term for where the two diagonals intersect right there, that point right there? What's that called right there? And take a look. That's congruent to that. That's congruent to that on the same segment. What do I call that? What do we got, Corrick?
Center.
We're not in triangles. Get out of triangles. That's not what I'm looking for here. Remember, this is all this is, guys. You're overthinking it. What's that called? Midpoint. Yeah, that's a midpoint. So the two diagonals of a parallelogram intersect at the midpoint. Keep that in the back of your mind for the last question today. All right, here we go. Have those. I think you'll need your calculators yet, but we're going to do no proofs yet. That'll be Monday. We're going to go algebra questions right now. So on question number 1, I have a 10 and I have a 2x minus 4. What are we going to do with them? And then I'm going to ask somebody why. All right, I need to solve for x. So what do you want me to do with the 10 and the 2x minus 4? Let's start this off right. Little number action here. Oh, here we go. Stephanie, what do you want me to do with those? Set them equal, yep. 10 equals 2x minus 4. I'm not really concerned about the algebra part. It's the why part today. Why are you doing it? So it looks like we add 4 over and get 14 equal to 2x. X equals 7. All right, here's where I need you locked in. Theorem used. What you write down right now is going to be the same thing we write down Monday in your reasons column when we start proofs. So that's why I'm getting you into this habit. First, you tell me you have a parallelogram. You were given that this is a parallelogram. So I have a parallelogram. And then everyone remembers the arrow implies. And then you tell me what property you just applied. All right, so parallelogram implies what property of the 5 did we just use to solve this problem? Shoom, Drew.
Diagonals bisect.
So that's what we write. Parallelogram implies diagonals bisect each other. All right, good. Let's go to the next one. There is no algebra to do here. All right, side TI. What do you have for me? Side TI, x equals, Alexi? 16, good. And then for my theorem now, you tell me parallelogram, because that's what I gave you, implies what property did Alexi use here? 2, Simon. There you go. Just guys, again, guys, getting you in the habit of what we're going to put in the reasons column come Monday for a proof. And number 3, what are you going to do with the 3x minus 2 and the 4x minus 10? Tess, what are you going to do with them? Okay. So what do I got there? X equals, move the 10 over, 8. And parallelogram implies what property was used here by Tess. Lauren? Okay. All right, so that's enough for the sides and the diagonals. Now it's time to work on the angles. And to work on the angles, I'm going to allow you to just work in your groups right now. All right, I'm not going to do any of these with you. Couple things, but don't get started yet. Couple things. I do not need a theorem. I just want you to find the numbered angles. No theorem. Also, do you need to use a parallelogram property every time? No. Hey, vertical angles are congruent. Use it. Linear pairs are supplementary. 180 degrees in every triangle. Also, I need you to get in this habit. It is okay to find a blank angle if it leads you to the numbered angle. That's okay. All right. So if an angle's blank, but you can find it and it may help you lead to another numbered angle, do it. So I'm going to give you guys plenty of time right now in your groups. go ahead those three problems and find the numbered angles. I do not need a theorem.
But we know opposite angles are congruent.
You are going to use your properties, yes, but some angles maybe you don't need them.
You guys don't have to do all that. Just 2 is 140 because there's and then the other 2 are 40 because they're supplementary. I see. It wasn't that hard. And then 1 in the next problem is 113.
Two has to be 20. 3 has to be.
Why does 2 have to be 22? Yeah, I guess.
Yeah, I'm stupid.
Wait, it's 113.
1 would be 113.
I said that like 5 minutes ago. I'll just show what was it.
I got one.
Two is 22. I thought it was more complicated than it was. Wait, I know exactly how to do this. It took me a second to figure it out. Oh yeah, 72 plus 47 is 118. So 4 plus 1.
That was these 2 questions were 7%. That's how I got it.
I only got this one. I think I don't know exactly how to do this.
Did you get? Oh, that's 2 is 72. Oh,
Otherwise, I do know how to do it. Wait, so this is 61. So 61 plus 40 is 101. 79, so 3 is 79. What do you know? Oh. Because these 2 are 54, so 4 is 54. And then 1 would also have to be 54.
Oh yeah, you're
54 was the 79 that's 3 plus 47 because the diagonal would have to be like 1 is the blank. Oh. And then you just subtract 20. It's not. Wait, let me double check this. I don't want to be wrong.
Divided by.
Okay, let's talk here. There might be some questions on the third one, and there's something you're not seeing that I want you to start seeing more and more when you do these parallelogram questions when we get to the third one. So here we go. First question there. Let's see, 40 degrees for angles 1 and 3, and I got 140 for angle 2. Not that big of a deal. Second one, angle 1, I got 113. Angle 2, I have 45. And angle 3, I have 22. So before I get to the answers on the third one, here's what I want you guys to try to remember. If at least one diagonal is drawn in a parallelogram, at least one, if both are fine, but at least one diagonal is drawn in, look for alternate interior angles. Because remember, the opposite sides are parallel, which makes the alternate interior angles congruent. So in that third problem you guys might have been struggling with, if that's 40 degrees, that given 40, that's got to be 40 down here because they're alternate interior. If that's 47, the given 47 degree angle, this angle's 47. They're alternate interior. So look for alternate interior angles when the diagonals are drawn in. So angle 1, I have 61. Angle 2, I have 72. Angle 3, a buck 8. And then angle 4, 32 degrees. Okay? So one diagonal is drawn in, look for alternate interior to help yourself out. Questions about any of those? 180 degrees in a triangle, you can use anything. All right, last one. Go ahead and please graph that parallelogram with W, X, Y, and Z, and please connect them to make a parallelogram. Last one here of the day. W, X, Y, Z, make a parallelogram out of it. And it's asking for, what's the intersection of the diagonals? Name the point that's the intersection of the diagonals. And I won't accept you guys just drawing them in and saying, oh, it looks like it's this point. I want to do it. You show me algebraically. You know it's this point. And we talked at the beginning of class, because the diagonals bisect each other, where they intersect is the midpoint, right? It's the midpoint of either diagonal. Okay? So what we need to do here to find the intersection is, hey, I'm going to take one diagonal, does not matter which one. They're going to come out to be the same midpoint. Take either diagonal and find the midpoint. And here we go for what? The 80th time? X1 plus X2 over 2. Y1 plus Y2 over 2. So you pick a diagonal and find its midpoint. That's where the two will intersect. And the point you guys get should look like the intersection of the diagonals on your own graph. 0, 1.5 or 3/2. Okay, add your x's, divide by 2, add your y's, divide by 2. Just make sure you're doing it on WY or XZ. Take a look at the bottom of your homework, where your homework's listed there. I just want to make it a point there. It does say for numbers 21 and 37 on graph paper, which means Monday, I don't want to see this on your line paper. This isn't on graph paper. This is what I call a ghetto graph. All right? No, it's not happening. All right? I don't want to see that. There's slices in the back if you need them. Slices of graph paper if you need to grab one and do the graphs on those. But they are not done on line paper and you hand drawing it. All right? Okay, get going.